Hello, everyone. Welcome to another episode of Science and Technology Q&A for kids and others. And I see a variety of questions here. There's a question here from Des. Suppose I wanted to store digital data in a way that would be accessible to archaeologists 10,000 years in the future. How can I achieve this? Suggesting thin aluminum or titanium punch cards, et cetera, et cetera, et cetera. Okay, there's an interesting problem. So, how does one communicate things across large periods of time? It's something where we can get some sense from looking at archaeological history going back 4,000 years, maybe 10,000 years, maybe a little bit longer. And the main conclusion is it's really hard. It's something where there are a couple of issues. One is the thing that you are putting data into something that will survive. And another is, will anybody understand what the data means, or even that it is data? So let's talk first of all about what survives. Rock survives for a really long time. Stone survives for a really long time. There are rocks exposed on the Earth that are, a couple of billion years old. Most rock is considerably younger than that, and there's a continual process of new rock being pushed up from the mantle of the Earth and so on. But there is rock that is, I think, as I recall, a couple of billion years old, because there are fossils that come from when life first emerged on the Earth, which was probably maybe 2.6 billion years ago or something. On the moon, the surface is original, so to speak, except where there's a crater because something crashed into the moon. So that means that the surface of the moon is 4.6 billion years old, give or take. So it's something where if you want to, there are things you can put on, the rock lasts a really long time. There are things you can put that will last a long time. So for example, things like quartz, form of rock, with etching in it would last a really long time, for example, on the moon. Actually, there's a friend of mine who's had a project to take random kind of beacons of our civilization and put them around the solar system. Even another group of people I know who are trying to get them into interstellar space. But the question of what you put there, first question is, you need something where the actual sort of writing or whatever it is will survive for a long period of time. And you can do that by etching things on things like quartz and on various kinds of metal. And in fact, there are even copies of books of mine in microscopic form etched into, I guess it's some kind of metal disc that might have made it to the moon. I'll tell you the story of that in a moment. There's some other things like that that made it at least into the trunk of the Tesla car that got launched out into the solar system a few years ago. But so that's the question of what the physical object, how long does it last? Well, the answer is you can probably have physical objects that last for billions of years if they're not in places that have bad things happening to them. Now, there's some things that I know haven't gone quite so well, like, for example, on the Apollo missions, there are these proud American flags that got taken by the Apollo astronauts and put on the moon. It's always a bit of a mystery when you see a picture of a flag on the moon. The moon has no atmosphere, no air, and a flag flutters in the air, flutters in the wind. So how come the flag that's on the moon is nicely kind of unfurled and sort of displayed with full flagness, so to speak? Well, the answer is it had to have a piece of wire at the top to keep it in that configuration, because there's no air on the moon to be blowing the flag out. But I gather that it's believed, at least, that the flags that were put there, the flag itself, the physical object, is absolutely still there after 50 years or whatever it is. But the design of, you know, the stars and stripes and so on the flag is gone. The thing will probably be white. And the reason for that is that the dyes that were used to make the flag have been there are enough kind of cosmic rays and other things that hit the moon, charged particles mostly from the sun, electrons, protons, and so on, mostly from the sun, streaming out along with the light from the sun, hitting the moon, and those things destroyed probably the dyes that were used in that. It's the same kind of phenomenon as that if you have books which are exposed to the sun, they will gradually lose their color. Usually the red dye goes first. Not quite sure why, actually. I think it may just be because of the chemistry of the red dye. Maybe. Probably that. But some thought required there. There may be an easier way to understand that. But in any case, so printing something in colored dye, not a good idea if you want it to survive a long time. Even in 50 years on the moon, you know, hasn't survived. But you know, having a thing sort of set in stone, so to speak, you can have that survive if nothing comes and sort of destroys it, could survive for 1 billion years potentially. You know, we see that in kind of the archaeological remains from, you know, a few thousand years ago, whether it's pyramids or whether it's, you know, temples and things or other buildings from antiquity on Earth. The thing that's always struck me is that, you know, you go and look at Roman ruins and things like that, and they have a certain form, and you kind of have this idea, oh, that's kind of what the thing was like. But it's actually hard to imagine what the city was like when it was really whole, so to speak, because there was a lot of stuff that was wood and a lot of brightly colored things, no doubt, that were there. And I'm sure it looked all rather impressive and so on. I have to say, many years ago now, I lived in California for a while and was in a place where the house I had was almost burnt down by a fire, but the fire happened to miss our house, but fortunately, but it burned down a lot of houses in the area. And the thing that was really striking to me was, you know, I'd known what these houses more or less looked like when they were kind of whole, so to speak. But after this fire, you drove through this fire area, and all that was left were a bunch of foundations of houses. And those foundations looked an awfully lot like the kinds of foundations that one sees when one looks at Roman ruins and so on. And so kind of the translation of what these houses looked like when they were whole versus what one was seeing post-fire kind of gives one some sense, sort of reversing that gives one some sense of how different these things in antiquity probably looked in real life. But in any case, so, you know, so we've got these things, they're kind of set in stone. And then we ask the question, well, what are all these squiggles on these pieces of stone? What do they mean? Can we understand them? And, you know, there are places where people are very interested in that question for the future. For example, when people are burying radioactive waste from nuclear reactors, you really kind of want a sign that says, keep out of here while it's still radioactive, and that might be 10,000 years. And so there's sort of a question of, can you make a sign that could plausibly be understood 10,000 years into the future, even assuming that sort of human civilization is not that different from the way it is today, in the sense that, you know, let's say going back 5,000 years, human civilization was sort of vaguely similar to what it is today. Well, that's challenging. And, you know, if one asks the question, what do these various things mean going back in the past, it's really, really difficult. You know, I was really struck a few years ago. I happened to be in Peru visiting some archaeological site that is a very old site. I think it's one of the oldest places in the Americas that has kind of existing archaeological remains. And it was a rather abandoned site, actually, but the person who was showing us around, I kept on saying, you know, what was that thing for? and they would say it was for ceremonial purposes. Translation, and we have no translation from modern times to what on earth this thing was for. It is, it's completely, whatever was its purpose, that purpose is now lost to us. Culture has changed to the point where we don't understand what it is. And there are plenty of things we can imagine from the current time. I mean, I don't know, you could say, what's the significance of, well, I mean, you could take the Eiffel Tower or the Washington Monument or something like that. What is it for? Well, it's just a monument. Well, the Eiffel Tower wasn't. The Eiffel Tower originally was a great big ad for things like bridge building technology. But that purpose is lost in that case. But it's really hard to have a translation of purpose. I mean, that's very short periods of time. It's hard to have this translation of purpose across sort of archaeological history. One of the more striking examples that I know of this is there's a thing, I think it's in Aleppo in Syria. There's a sort of a wall which has paint still on it. It was in a cave. And the paint is black and red, and it's a bunch of squares. And the squares are in some arrangement. And it's like, what on earth is this? It's from 11,000 years ago. What was somebody thinking when they made this? We have no idea. There are handprints in caves, paint handprints in caves. Are they just, was it just somebody who was, or some group of people who was sort of randomly, dipping their hands in paint and sticking them on the edge of the cave? Or was the pattern of these hands some incredibly significant thing that related to some, grand ceremony or some other thing that was happening there? We don't know. And the places where we kind of do know, where there is, for example, language that's been passed down, well, we have some idea when there's a representational picture of somebody, hunting an animal or something. Insofar as that representation has remained more or less constant to today, we can recognize it. And part of the reason it's remained constant is that when we draw a picture, we're not keeping sort of every pixel just like it was if we took a photograph. We're interpreting it and showing the edges much more strongly than we're showing the interior of things, and so on. We're kind of making a sketch based on the actual visual form that we see. But our biology has remained constant over very long periods of time, actually. And the ways that our eyes pick out edges and things like that have remained very constant. I mean, not just for humans, but going back probably hundreds of millions of years into evolutionary history, kind of the basic hardware that's been used to process images in our brains has remained pretty much the same. And that means that the picture, that what somebody chose to highlight at least in terms of, making the outlines of the animals and things, is pretty much the same as today. I could imagine something where somebody had drawn a form of picture where, I don't know, some pieces of quotes modern art, where in their moment people were knowing, oh yes, that's a reference to this cultural thing, and it's not a soup can, but it's some other, cultural reference of the day. And, it is not directly representational art. And at a different time, it will be completely lost what on earth that was referring to. Well, so, there's a big challenge of sort of understanding across history what things mean. And I think that the thing that is there are particular languages where we can see what this meant, and sometimes there are challenges, and sometimes, for example, hieroglyphics, the language of ancient Egypt. There was a question of how was that decoded. It was decoded in the 1800s, and a key thing was that the Rosetta Stone was found, which contained the same passage kind of given in 3 different languages. It's kind of like that was the early version of the machine learning way of learning language translation. In modern times, like between European languages, there are just, gobs of pages of EU regulations that are translated into the many languages of the European Union. And the fact that there is this sort of parallel text between those different languages is how the machine learning systems learn to do language translation. It's actually not just regulatory stuff from governments, it's also things like computer manuals and websites and so on that have been translated. But it's sort of amusing that the way that Egyptian hieroglyphs got decoded is really sort of the same idea, except that now it's billions of pages of text. And then it was just one big, stone slab that's now in the British Museum, so to speak. But there were other forms of ancient writing that have been very difficult to decode. Linear A, Linear B from Crete was a big thing in the 1930s, 1940s. When one of those was decoded, the other one has never been decoded. I can't remember which one is which. But and there are other places and things where we have things that sort of look like writing, but it's never been decoded, what that means. And usually to have a sort of a decoding, you have to have kind of this thread of history that connects one back to that time, not only in terms of the writing, but also in terms of the concepts that are being expressed there. I think I skipped over something I wanted to say, which was about stuff that gets to survive for long periods of time. And I was mentioning the moon as a place where you can keep stuff for long periods of time, at least until the moon becomes a tourist destination and everybody's picking up all the artifacts and so on and saying, oh, this is really cool. It's been here for 200 years. Now I'll pick it up. But if that's not being done, then in terms of just being there, if nobody's disturbing it, it will stay for a long time. I was mentioning that some stuff of mine that was on these, I guess they're metal discs, that might have made it to the moon. I should have explained what I mean by might have made it. And this was probably, when was it, 2018, I think. There was a spacecraft, actually, an Israeli private spacecraft that was going to the moon, the Bereshit lander, and this friend of mine had managed to hitch a ride for the package from his, it's called the ARCH mission, ARCH mission project of kind of delivering little packets of material from our civilization to be stored in places around the solar system. Well, anyway, the package got put on the lander. Unfortunately, the lander crashed into the moon at about, 2,000 kilometers an hour, I think. Something, when you're going to land something on something like the moon, it's in orbit around the moon. It was in orbit around the moon. It has to, when you're in orbit, you're going round at a certain speed. For low Earth orbit, it's like 17,000 miles an hour. Lunar orbit, I think it's 5,000 miles an hour, if I'm not mistaken, is the speed that you're going in sort of low lunar orbit. And in order to actually land on the moon, you have to stop going around and just start going straight down, so to speak. And you have to go straight down and stop before you hit the surface. Well, unfortunately, in the case of this spacecraft, it seemed not to have managed to sort of stop going around really fast. And it crashed into the surface at, I think it was about 2,000 kilometers an hour, if I remember correctly. And the question is, well, what happens to a spacecraft that crashes into the moon at 2,000 kilometers per hour? And you might say it doesn't have a hope, and it'll be vaporized. And in fact, somebody I know who had a rocket company which had, unfortunately, rather unsuccessful launches, gave me the analogy of, imagine that you take the main gun from a battleship and you fire it, a shell, into a piece of concrete. That's the effect that you will have at that speed. Well, and so it seemed hopeless. Then actually, a few weeks later, the Lunar Reconnaissance Orbiter, which takes high-resolution imagery of the lunar surface, went by, and it saw the landings, the crash site. And I sort of got curious, because we realized that because the thing was kind of going, had not really deorbited the moon properly, it was still going at sort of skating along the surface of the moon at a high speed. It was going down, but it was also going along the surface very quickly. And I found a person who was an expert in cratering, and asked kind of what would actually happen. This was, I think we worked out it was about a 15-degree angle, I think, when it hit the moon. And what happens at that speed when you hit the moon? And we'd worked out there was a lost picture that had been taken of the lunar surface by the spacecraft. And from that picture, you can see the configuration of craters. You can figure out where that picture was taken. Then you can figure out where the crash site was from the pictures from the lunar reconnaissance orbiter. You can just make a line between those. You can see what the direction thing was going in. And so you can see when it hit the moon, where was it kind of skating along the surface of the moon? So I for various reasons, I think somehow I ended up doing the calculation of what would happen to a thing that hits the moon at that speed, and et cetera, et cetera, et cetera. Well, if all else, if it was just a thing that was going on the moon at that speed and so on, you can work out based on the friction of a thing sort of just rolling along the moon, it would have gone for a couple of kilometers before it stopped, assuming it didn't run into a boulder and go splat and so on. But anyway, the person who's an expert on cratering told me that at that angle, things just bounce. They don't, if they're coming in sort of straight down to the moon, yes, they just go splat and they make a crater. But if they are coming at that acute an angle, they kind of skid along the surface of the moon. And in fact, knowing that, one can look at the pictures from the lunar reconnaissance orbiter, and one can see that, yes, there's this lovely ray that you can see in the picture which kind of goes out in exactly the direction you would expect from the crash site. Now, what makes that lighter ray? Not so clear, because the lunar surface is covered with this kind of sand-like stuff, lunar regolith, and what makes the thing, when it's been sort of abraded, turn lighter wasn't totally clear, but it's at least something was changed there. So anyway, the expectation is that the little package of sort of interesting things from our civilization on, I guess, quartz discs and metal discs and so on, probably actually survived the crash, and it probably skidded along the lunar surface, and it's sitting somewhere on the moon. So in any case, the question of whether anybody will understand what's in it at any point in the future, if one goes, thousands of years into the future, is a quite separate question. A lot of that question depends on the future of human civilization, which is quite a separate issue. But if we just ask sort of from history, what kind of thing would likely lead to that kind of sort of long time understanding, it's an interesting question. People have done some slightly goofy things, in my opinion, along these lines. People, when the first spacecraft was sent into the outer solar system and beyond, there was sort of the question of what should you put on them that would kind of talk about how wonderful our civilization is and so on. And so the Pioneer spacecraft that are now, there are two of them, that are now far outside the solar system, and I guess we've lost contact with those particular spacecraft at this point. Yeah, I think that's right. Launched like 40-ish years ago. Those spacecraft have these plaques on them, which were intended to kind of be well, you could say a thing where, on the spacecraft, it could say, property of the human species on planet X. But no, they were plaques that were intended to represent something about the human civilization and knowledge. I don't think they were terribly successful. I mean, of course, we don't know. Nobody has come saying, "Oh, we found your plaques," and this is what we think based on them. But they had a very strange representation of kind of the solar system and the position of a picture of a couple of people and things like this. And then I think one of the worst parts of this plaque was there needed to be a way of representing distance in order to kind of give a sense of if this spacecraft is found 1 billion years from now somewhere else in the galaxy, there's the question of where did it come from? And the idea was to show the position of the Earth by using its position relative to pulsars, relative to neutron stars, rapidly rotating, rotating neutron stars that produce intense radio emissions. And now I'm wondering, if you really waited 1 billion years, I'm sure those pulsars are all in completely different positions, because there's the rotation of the galaxy every few 100 million years. And I don't think it doesn't rotate rigidly enough. I think they end up in different places. So I'm not even sure that makes much sense. But assume the pulsars are still roughly in the same place. It's actually a thing people imagine using in the near term as a sort of interplanetary GPS system, because GPS is based on satellites in orbit around the Earth. And so if you're far away from the Earth, you don't get to use it's not useful to use the terrestrial, even if you could pick up radio signals from them. Those radio signals will just give you information from knowing the distance to the satellites in different places in Earth orbit. And if you're out in the orbit of Jupiter, for example, it doesn't really do you much good. So you have to use some more global way of telling where things are. And one thing you can do potentially is to look at the directions to pulsars, and that can tell you where you are in the solar system. But anyway, this was a kind of pictorial version of that. And so one of the issues was to mark off what the actual distance to these different pulsars is. And there's a question of what is the unit of length that you use. So the thing that I consider this the worst part of this plaque was to make a specification of what the length was. Now, you might have thought you would just draw a line of that length, or it might be the size of the spacecraft or something like this that would be the length measure, but no, it was not. Instead, on this plaque, there's a picture that shows kind of two circles, and one of them has an arrow pointing up, and one of them has an arrow pointing down. I think I'm remembering this correctly. And that's somehow supposed to indicate a measure of distance. Well, the problem is, what is that? Well, if you're a physicist from the 20th century and you were educated in quantum mechanics, you might possibly have seen pictures a bit like that in quantum mechanics books. What that was supposed to represent is a phenomenon in quantum mechanics, the so-called hyperfine splitting of hydrogen. It is the thing that happens when you have electrons have a spin. They're little particles of charge with charge, and they also spin around on their axis, at least in some conceptual sense. And when protons do the same thing, when the protons and electrons in a hydrogen atom are aligned, the hydrogen atom has one level of energy. When they're anti-aligned, it has a different amount of energy, because it's like having bar magnets, where the bar magnets, bar magnets like to arrange themselves, if one bar magnet is north is up, south is down for its poles, then you put a bar magnet next to it, it will like to be south is up, north is down. Same with electrons and protons. And so there's an energy difference, and that energy difference, when a hydrogen atom makes a transition from one of those energy states to the other, it emits a photon that is a radio frequency photon that has a wavelength of about 21 centimeters. And that picture was a representation of the electron-proton spin flip transition, imagined to be emitting a photon of wavelength 21 centimeters. And so the answer, to the quiz, so to speak, was the measure of length was 21 centimeters. But the problem with that is that whole representation of electrons with arrows and things like this is an incredibly human-specific, 20th century physics-specific interpretation, not least because the way electron spin works and so on, it's not really rotation, it's this notion of a spinner, it's a complicated kind of mathematical construct that it just happened to be a convenient thing to think about in terms of a direction and arrows and things, and that was the way it was first imagined in the 1920s. But doesn't necessarily have to work that way. In our model of physics, for example, the natural representation of that kind of thing would probably be something completely different. So to my mind, it's kind of a goof in terms of being able to represent sort of something in a time invariant way, because you're really locking it down to 20th century physics, which is presumably not the intergalactic standard of representation of physics. So then came the am I getting these the wrong way around? Which came first, Pioneer or Voyager? I'm forgetting. Maybe it's no. I think Voyager came second as a deep space probe. I always used to be a big enthusiast of these spacecraft when I was a kid, but I think these ones were launched right after I was a kid. I knew about the spacecraft, the first spacecraft that went to Mars and Venus and places like that, and I could no doubt tell you all about. I haven't thought about it in more than 50 years, but you know, Mariner 4 spacecraft that went to Mars and so on. It's worth remembering, just in terms of how history evolves, that when I was a kid, let's say that spacecraft was probably 1965, 1966, something like that. People still were pretty convinced that there was life on Mars, and that one was seeing, as the seasons on Mars changed, one was seeing these different vegetation colors showing up in different parts of the Martian surface. And it's worth remembering that when the Viking landers landed in probably 1976-ish timeframe, maybe a little earlier than that, many people were, you know, kind of expecting they would find microorganisms in the Martian soil. And the fact that, you know, it was generally thought it's probably the case that there's life on Mars. And it was sort of, it's that recent that one sort of has thought that there probably isn't, at least not in any form that can easily be recognized, so to speak. So, but back to this question of sort of transmitting information over long periods of time. So in the Voyager spacecraft, there was a let's show off the Earth's achievements. There was a record, a phonograph type record, you know, thing with I don't even know how to describe this anymore, because it's like, I would say it's like a CD, but people might not even know what CDs are anymore. The rotating thing that had little grooves in it, that was the original way that record players, gramophones, whatever, worked. Back in, certainly when I was a kid, there would be plastic vinyl records, and they have little grooves in them in a big helix, and there's a stylus with a needle at the end, which would kind of ride around that groove in this helix, and depending on the height of the thing would be sort of etched out, and depending on the height at a particular place in that in that groove, you would get different sound intensity. Excuse me. So in any case, that was, you know, to somebody in the 1960s, 1970s even, a record player was a completely obvious kind of piece of technology. The stylus, it rides the helical grooves. It you know, plays a sound based on the height. So on the Voyager spacecraft, there was a record that had recorded a bunch of music from around the world that was recorded in this kind of way. Okay, well, in today's world, even right now, you know, 45, 50 years later, it's like a weird object. It's like, how do you play this thing? If I had one of these, you know, you can obviously still get sort of traditional record players, but it's a dwindling kind of thing. It's a you know, buy it only as a retro kind of thing to do. And on that particular spacecraft, there was sort of a diagrammatic explanation of how you play the record. And I must say, I think it was, even in today, it's sort of incomprehensible. because it sort of had an implicit assumption about, well, everybody knows how these phonograph records kind of work. You know, to give a sense of the times, when I was a kid, probably age 15 or something, I happened to spend a week or two at a company in England that was thinking about making video discs. This was at a time when there were records that were there were like, I think they had 33 revolutions per minute, is that right? And then there were 78 revolution per minute, smaller records and so on. But the idea was to make a video disc where there would be the thing would be spinning fast enough, you could have enough data on it that you could encode the information for a video. The problem was that records had this habit, they're made of plastic, they had this habit of picking up static electricity. And so you would end up with this big static electric charge. And the problem was, if you spin it very quickly, it's just a feature of moving charges that they produce, they'll have, with a current flowing through the stylus, they would have an electromagnetic force on the stylus. And so depending on how much static electricity there was on the surface of this spinning video disc-like record, you would have a certain different amount of force pushing the stylus up or not. And the problem was, if something were to discharge the electricity that was on the surface of this record, the stylus would be pushed down with some force and wouldn't respond quickly enough. It would just grind itself into the record. So the question was, it's an early practical physics project of mine, was to understand the static electricity and to even be able to measure sort of where the static electricity was on the record. Was it at the surface? Was it somehow embedded in the interior of the plastic and so on? So I had this lovely experiment, which I'm not sure if it was ever done, that involved figuring out, by dissolving the record in some very aggressive solvent, being able to figure out where the actual charge in the thing was. But in any case, in the end, the technology of video discs got built. The video discs were built for a short while, but they worked differently, and they didn't involve physically touching the surface of the disc. They were involved a laser being able to, just like a CD, a laser just being able to, well, and that was how DVDs worked subsequently. A laser just seeing different transparency of the material in different places, rather than a physical thing riding on these grooves. But in any case, back to the question of how do you make something that people are going to understand 10,000 years in the past, 10,000 years in the future, whatever. I think it's super challenging. You have, there are all sorts of interesting examples. I wrote a piece a few years ago, actually, about this in connection with the original effort to send little sort of beacons of stuff around the solar system. It's like, what do you put there that has any hope of being able to be understood outside of our very specific sort of point in the history of civilization? I mean, I should add that the whole idea of, the aliens are like us and they're going to be able to read this stuff, I really don't think is right at all. I think there's this kind of distance between us as the sort of us in our way of thinking about the universe and other ways of thinking about the universe. That distance is quite great, and it's the notion of what it counts to have as being sort of an alien, I think, is intelligence, is a very, very, very messy one. So I don't think it's, I think the question of sort of how far apart are the alien civilizations, both in physical space, like how many light years away in different stars and so on, plus how far away in what I call rulal space, the sort of space of different interpretations of the universe are they? And if they're far away in the different interpretations of the universe, they can seem to us like something just completely incomprehensible. But in any case, ignoring that issue, by the way, I see a comment here that people commenting that vinyl records are becoming more common again. Okay, great. So then by the time somebody can go out and chase after the Voyager spacecraft and capture them, the people will understand what the people who go do that will understand what the instructions for the record player actually meant. In any case, I think it's talking about what it was kind of talking about what you can do to make something that's understandable over long periods of time. Looking back at archaeological history, there are all sorts of places where people tried to sort of put messages for the distant future. I think one of the more interesting ones, 4,000 years ago or something now, in Babylonian times, for example, people who would build some big structure, a temple, a citadel, whatever it was, they would always put a message, in the foundations that said, basically, to anybody who's destroyed this object, you're cursed, more or less. To imagining that somebody will come in as maybe they had in conquering some other place and destroy the structures there. It's like, well, when you destroy it right down to the bottom, you get to a message saying, you're cursed, more or less. But people would put up these different things. There's one famous one, let's see, Darius, king of the Persians, I think, had this big sort of well, not quite a plaque. It's on the side of a mountain somewhere in, I think, Iran now, where it was kind of recited the great acts, well, at least the acts of conquest of this chap Darius. And I think it begins, it's sort of a famous thing because it begins, I am, I think, Darius, king of kings, et cetera, et cetera, et cetera. There's in the kind of cultural collection, there's this Shelley poem that's about a somewhat different thing. It's about, I think that's about Ramesses II, an Egyptian king, who, and it's a poem. I always liked this one when I was a kid. I don't know why I liked it. It's sort of a downer of a poem, because it basically says that there's this, there was this giant statue. It's now in the desert, and I think the poem talks about two vast and trunkless legs of stone. So it's the legs are still there, and then somewhere at the base of this big statue, or the former statue, is this plaque. I am Ozymandias. I think that was another name for Ramesses, king of kings. Look on my works, ye mighty, and despair. And of course, this is a reference to the fact that, at the time, that was intended to be, look at all this great stuff I built, nobody else will be able to match it. And by the time it's found archaeologically, so to speak, very little is left. And one could read that in a different way, of the fact that it's whatever empire there was there has crumbled, and so it goes with such things. But in any case, this kind of whole question of what do you put, and what do you say, and even when you read kind of the thing, I think it was from Darius, this whole sort of thing about his military conquests and all this kind of thing, it reads in a very silly way, in a sense, to us today. It's not the way something will be written today, and cultural difference to that time. But I think in this question of even knowing sort of that something was put there on purpose, even knowing that this thing that you had that was an actual thing that had human thought put into it, so to speak, is not trivial. I mean, you find a flint from 1 million years ago or something like this, and it's like, was this a flint that was carefully knapped by some predecessor of ours, or is it just a flint that broke off from something and lay on the ground? And you see that quite a bit with people asking, was this something made by, I don't know, even Native Americans from not that long ago, was this, way that this piece of earthwork was organized. Actually, I remember when I was a kid in England, there were, you would see these pits in woods particularly, and it was very unclear whether these pits were fortifications from Neolithic times, places where bombs had fallen in World War II, or something completely different. And, it's very hard to tell whether this, the mounds of earth that have been put there, what was kind of the thinking behind what was going on there. And I think it's a very challenging thing to see when was their purpose in something. This whole question about the identification of purpose in things is a very interesting philosophical and practical question. I mean, in a sense, it's kind of like asking, it's a version of, was this thing done nefariously by somebody for some particular purpose, or did it just happen that way? Or is there if you're kind of trying to find, the lost city of Atlantis or something under the ocean somewhere, and you're scanning pieces of the ocean, it's like, can you tell if that rock, arrangement of rocks at the bottom of the ocean was actually the citadel of Atlantis, or whether it was just a random pile of rocks produced by oceanographic or geological processes? So there are lots of interesting questions around that. Let's see. Oh boy. Let's see if there's some memes is commenting. I wonder how vinyl would hold up in space. I don't know the answer to that. I think I was just talking to a friend of mine who's making some stuff that's going on a Jupiter probe, and the thing it's an antenna assembly, and it has epoxy resin in it, and they were just testing it by putting it, so Jupiter has a very strong magnetic field, and it collects a lot of charged particles from the sun get trapped in that magnetic field, so there's intense radiation around Jupiter. And so then the question is, what happens to epoxy resin when it's put in intense radiation? So apparently they've been testing it by putting it next to a nuclear reactor somewhere, which has lots of radiation coming from it, to see what will happen to epoxy resin. I don't know the answer, but that would be some kind of proxy, perhaps, for knowing what would happen to a vinyl record when bombarded with lots of cosmic rays and things like this. Let's see. Oh boy. All right, I'm going to try and pick out some questions that are sort of related to things I've been talking about. P-Quill asks, could the Earth ever get a second moon? What kinds of effects could this have? The question one of my kids asked when they were very young was, when there were dinosaurs, could the Earth have had two moons? And I kind of use that as an example of a question that sounds really straightforward, but it's actually really hard to answer. And I think the answer to that particular question is, the Earth couldn't have had two moons 65 million years ago, but possibly a billion years ago, there could still have been another moon, which got maybe a couple of billion years ago, there could have been, that got torn out of the orbit and or crashed into the moon, as the moon is. Something did crash into the moon, because one side of the moon is really very different from the rest of the moon. And there are theories about how the moon formed. That the big splat theory seems to be the popular one, that something crashed into the Earth. The Earth, a lot of stuff got vaporized, got liquefied. It all went out into space. One piece of it condensed into the moon. Another part of it is the Earth, and so on. But this question of whether one could have had a second moon that got sort of ripped away from the Earth by something, or crashed into the moon, for example, is still kind of an open question if you go far enough back. Could the Earth capture another thing that is a moon-like thing? Well, the main problem is things that just sort of wander by tend to be going pretty fast. You know, it is the nature of mechanics, Kepler's laws in particular, that if you're a certain distance from the sun, you're going to be going at a certain speed to maintain yourself in orbit. So you're either in orbit or you're not in orbit. If you're not in orbit, then how come you're still around at all? Why didn't you just fall into the sun, billions of years ago? If you say, well, what about something that came from another solar system, for example, an interstellar meteorite or whatever else, or interstellar, asteroid or something like this. The issue with that is if you tend to be, you're not captured into orbit around the sun, you're going at a very high speed. So this Oumuamua thing that was observed a few years ago, this very elongated object was, what was it, five years ago or something, a little bit more than that maybe now, that was observed transiting the solar system, going through the solar system. The way one knew that it probably came from outside the solar system was it was just going too fast. It wasn't something that was in orbit around the sun. So in order to be something that gets captured by the Earth, you have to be going fairly slowly to be able to be captured. The moon is going at a certain speed. In order to be captured into orbit with the Earth and the moon, you have to be sort of going slow enough that you can be captured that way. If you did get captured, if an object of significant size did get captured that way, it would have all kinds of effects. I mean, I would say, by the way, that the Earth and Moon are kind of strange in our solar system, at least, for being a planet and its moon of fairly comparable size. Most moons of planets are really tiny compared to the planets. In our case, the moon is pretty big compared to the Earth. And that means that when you look at orbits, so if you're orbiting the Earth in low Earth orbit, you're just going around the Earth, it's all good. Even going around the moon is not trivial, because there are effects from the gravity of the Earth at the position of the moon that make it not be the case that what would be kind of a stable orbit around the Earth, because there's not so much effect of the moon's gravity, because the moon is enough smaller than the Earth, those orbits are not stable around the moon. And so I don't know what the, it's a much more complicated story. And as you get to sort of high lunar orbit, it gets even more complicated. And this question about sort of how do you keep yourself in stable orbit around the Earth and the moon, a very non-trivial question. And it's not clear that things stay that way. There are things that kind of end up sort of little asteroids and so on that end up being sort of captured by the Earth for brief periods of time, but they don't stick around very long. So I guess that those must be those must be rotating along with the Earth. I am not quite sure how that works exactly. They must be migrating from the asteroid belt to the position of the Earth, but sort of co-rotating with the Earth around the sun, and then getting briefly captured by the Earth, and then escaping from orbit around the Earth subsequently. And I don't know how long they last, maybe years or a few years or something, small objects that are captured that way. There's also the whole question about, which I always enjoy just for its name, the moon question, of whether there can be things that are, just like the Earth is going around the sun, the moon is going around the Earth. Can you have a moon that's going around the moon? And as I just explained, it's kind of hard to have a stable orbit for one of those. But I think it's more possible probably for other planets to have such a thing. And obviously, when you have an artificial satellite, you can think of it as, going around the moon. You could think of it as a moon in that case. Let's see. There's a question here from Gist. What should we do today to help the survivors reboot civilization after a cataclysmic event? I think it's perhaps interesting to look at human history so far and ask the question of how that's worked. And, well, it hasn't worked very well. I mean, I think that insofar as there's knowledge, for example, for antiquity, that was from ancient Greek times and so on. There were all these books that were written about science, mathematics, whatever else, literature, and so on. And how did they survive? Well, they survived mostly in the Arab world, being copied progressively, sort of being kept in storage, so to speak, by being progressively copied and then surviving to modern times. But there's not a lot, I think, where it's just like, oh, it was found many years later. I mean, the one that comes to mind is the Dead Sea Scrolls, is an example of something which was just found many years later. And actually, there are other examples of works from antiquity which were sort of lost. I mean, I think Cicero, for example, famous orator and essayist and so on from antiquity, Roman one, I think it was believed that none of his works had survived. And then sometime, maybe a couple of hundred years ago, somebody found in some, stored in the Vatican Library were these works. And so they've been kind of lost through just being misplaced, so to speak. But I think this, the continuation of knowledge is quite non-trivial. It really has to be a thread of sort of progressive passing down of knowledge from one generation to another. I think, when we look at something like the Antikythera device, this kind of clockwork computer device from around 2,000 years ago, there's just one example of such a device from antiquity. Nobody really knows. I mean, it's now known how that particular one worked. It's been sort of decoded what it was. It's some astronomical computation thing done with essentially clockwork. But in the intervening years and until modern times of computation, it would have been hard to interpret that thing. And, I think that's an example of, even if you find it and it was found sort of by chance around the 1950s, I guess, it's still, out of its cultural context, it's really hard to interpret. I mean, if it had been found in 1700, it would have been much harder to interpret what the thing was. So, I think it's pretty challenging to have things where you can do a cold reboot, so to speak. It's one thing where you have a continual thread of knowledge that's been passed down. In a sense, that was the point of the universities starting in the 1200s, and in earlier times there were things like Plato's Academy from 4th century BC. The sort of the original point, in a sense, of the universities was passed down knowledge from one generation to another. I sometimes think that that's been a little bit lost sight of in some cases in modern academia, but that is a pretty useful thing to do to sort of keep civilization. By the time people say, let's just forget about the historical knowledge, that's kind of a mistake, because that is the kind of that is what our civilization has, is this whole long thread of historical knowledge. But I think that being able to do the cold reboot seems really quite challenging, not least because if you have, you've got a laptop and there's been some cataclysmic event on the earth and you've just got this laptop, but it has a whole complicated chain of things. You need electricity to power the laptop. You need to be able to, maybe all kinds of things that, you boot the thing up and it's like, hello, where's the internet? And, the internet is long gone. There's a whole, these technologies and these things we rely on tend to sit on top of a pretty large network of capabilities. And it seems it's quite challenging. I mean, it's the same reason that, in different countries, it can be difficult to get to the point where you are manufacturing laptops, for example, because there's just needs to be an awful lot of stuff underneath that to sort of support that activity. And I think the same is true with just the unidentified sort of preserved laptop, so to speak, is probably not enough. Even if you knew to open the thing up and press the power button, it's like, well, you've got to have this whole infrastructure to support it. Let's see. Harry comments that they've liked the idea of putting Wikipedia and other literature in glass and sending it on 1,000-year orbits for future generations. Yeah, there are, well, as I say, this Arch mission project has tried to put it in things in the solar system and things on the moon and so on. I think it's an interesting little challenge. If you could imagine, it's kind of like the time safe, where you say, you know, the safe can't be opened until 7 in the morning or something. And what's the analog of that on a larger scale? Well, one analog would be you put a bunch of stuff in a spacecraft into some kind of orbit that's a bit like a comet, where it goes out to the outer solar system and then comes back in 100 years or something like that. And you could imagine sort of having things where it's like, let me send you a reminder. You know, it's gone for 200 years, then it reappears in Earth orbit, and hopefully people notice it. And then it's like, oh, I'm back again, and here's the stuff to look at. Kind of reminds one of these kind of time capsule type things. I did a little bit of a study of time capsules where people sort of store stuff to be found many years later. The story of time capsules is truly dismal. People when they build buildings, when they have events like World's Fairs and things like that, there's a habit that people have had of, let's put a box of interesting artifacts from the current time in there. Let's bury it in some foundations. Let's do this or that to it. And then people will find it in a few hundred years. The story of that has not been good. Most of those things end up being in horrible disrepair and not necessarily to be found successfully in the future. And I'm just trying to remember, there was one, oh yeah, I'm just a funny story. There was a well-known mathematician, physicist named John von Neumann, who died in 1956 or 1957, and who I had heard the claim that he put aside this box that was supposed to be opened 50 years after his death. And I happened to be talking to his daughter, who said yes, and actually just before the time when that 50 years would be up. And then and I was sort of asking later, what happened with the box? And she told me it was a big bust. They'd assembled sort of all the descendants. They were going to open this box, and it turned out it wasn't even a box from the person they thought it was a box from. So it was a big bust, so to speak. But that's, unfortunately, these sort of time capsule ideas have a terrible habit of not panning out in a good way. I could give you a lot of other examples, some rather of sort of failures in the effort to have these very long time things. And usually the issue, as I say, is this lack of in a sense cultural connection between what happened then and what's happening now. And I think that is, it's a little bit of a sobering thing to realize that we live in sort of a particular time, and transporting us to different times, it's challenging to see how one sort of fits in. Aaron is asking, have you considered printing chunks of orphan language or something onto something like microfilm, just as a fun artifact or toy? Actually, that has been done. I even have one somewhere here. I don't know, I could probably find it. That was a copy of the stuff that was sent to the moon and other places. It's done with something similar to, it's sort of a photolithography technique, similar to the one used for making microprocessors. But in this case, it's just taking writing and making it very small. Philip is asking, is the fact that the moon exactly covers the sun during an eclipse just a coincidence? The answer is yes. The moon is progressively moving further away from the Earth, and it will no longer cover the sun in a while. In earlier times, the moon was closer to the Earth, and it would have more than covered the sun. So the fact that we live at a time in history in the history of the Earth, when the moon just about covers the sun with a little tiny bit sticking out around the edges, during a total eclipse. Well, really nothing sticks. The actual disk of the sun is covered, but there are prominences that you can sometimes see beyond the disk. It's a coincidence of our times, and the dinosaurs would have seen it differently, and in the future it will be different. And for example, in most other planets, their moons are really tiny compared to the sun. Like in Mars, for example, its moons are really tiny compared to compared to the sun, even at that distance, right? All right, I need to get going soon here, but let's see, there's maybe one more. Astronomy is commenting here. Detecting the signatures of technology of other civilizations will be very difficult or impossible if they don't want to be seen easily. Stealth and camouflage is a survival tactic in the wild. Yeah, I just think that the sort of philosophical aspects of what it means to have an alien civilization are very complicated. I mean, the quote that I'm fond of giving is, the weather has a mind of its own. It has computational processes going on that are not that different, perhaps, from the computational processes going on in our brains, but yet we are not well aligned with the computation, the intelligence of the weather. So to us, it's a deeply alien kind of thing. The interesting case right now is AIs and the alignment of sort of the intelligence of AIs with human intelligence, and the fact that we've created the AIs for the purpose of replicating human intelligence gives a certain degree of alignment. But we can also perfectly well, you take a neural net, you take ChatGPT and you scramble its neural net weights, and it'll go yak, 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 and it'll say something. It'll get this random sequence of words, and it'll be like, somebody might say that's brilliant sort of modern poetry made by the ChatGPT that has evolved far beyond our human capabilities with its scrambled neural net weights. Or we might just say it's nonsense. And distinguishing those is quite difficult because, the thing will do something. Now, the question of saying, is that something that we consider interesting or, a sign of intelligence? It's got the same, let's take that thought experiment. ChatGPT has 175 billion weights, basically, all carefully tuned based on the trillion or so words of actual text that it's read from the web and other places. But, with those weights, you give it a prompt, it will start trying to continue that prompt in a way that is like what it has read on the web. So, if every sentence that starts, the cat sat on the mat, if every sentence it read on the web has the word mat in that position, if you type in the cat sat on the, it's going to say, okay, I know how that goes on, it's mat. I read that from the web. And that fact is encoded in all of those weights inside the neural net. Well, now let's say we come in, we scramble the weights, or maybe we don't scramble them. We use some incredibly brilliant algorithm that does something very notable. I won't say clever, but notable to those weights. Then we do the cat sat on the, and it says moon, for example, next. And we're like, we could say, that's just crazy, that's nonsense. Or we could say, okay, you just evolved to some new state of intelligence where, it keeps going, the cat sat on the moon, where, I don't know what, make up some, where the, I don't know, it's hard to make up nonsense. We're all programmed to kind of follow language in the way that we're used to language. So it's actually hard to start generating kind of pure nonsense stuff immediately. But in any case, we can certainly imagine that. And then the question is, if we look at that thing, that alien intelligence that wasn't perfectly aligned with sort of human language and human text, it's like, what does that mean? Is that an alien intelligence, or is it a scrambled neural net that is just broken? Who knows? Hard to tell. We have plenty of examples you could point to examples of, I don't know, various forms of modern art, for example, where you say, is that just a splotch of paint, or is that some very meaningful thing that has some great significance for people? Often, to know the answer to that, you kind of have to have the lineage. You have to have you have to know, how did it get to that splotch of paint? What was the story that the artist would tell about that splotch of paint? And so in the case of, when you have this sort of scrambled neural net, if there was a big story about how it got scrambled, maybe you could have a better idea. Is that a brilliantly scrambled neural net, or is it a random broken neural net? But I think it's a very very challenging thing to kind of recognize what it means to have sort of an example of intelligence. And we have this good example of alien intelligence in AI and so on, and we could make it even more so by taking the bits of the AI and sort of scrambling them in some way. Then the question is, if you're an alien intelligence and do you want to be found, do you not want to be found? Is there even a meaning to the question of being found or not? If it's the case that, what's a good example? I mean, the AI system that's just running this computation, and does it quotes want to be found? It's not clear it wants anything. We can put, as humans, we can kind of project our experience of wanting being associated with things, but that's not something that we can say intrinsically, this bag of bits wants this thing. That's the notion of wanting something is a human notion. We can say the bag of bits behaves as if it wants such and such a thing, but it's an internal human notion when we talk about wanting things. At least that's the way we talk about it today. Maybe in the future, when AIs are well integrated into civilization, and we have the humans, we have the AIs, everybody's living hopefully happily ever after, and the AIs have their own sort of intrinsic behavior. They have their own sort of civilization of the AIs. Then there's sort of the question of that. Then you perhaps can then the word want might actually be applied. We might choose in the future to take the word want and actually apply it to the AIs that are sort of autonomously existing in the AI civilization. Or we might have a different word. We might have, I want or something for an AI wanting something different from the human notion and feeling of wanting something. Anyway, I tend to think that this question of, I think it's too much of a human reading of things to talk about sort of, would an alien intelligence, quotes, want to, quotes, camouflage itself? I think the challenge, it's kind of, what's a good analogy? I mean, it's kind of, let's take the weather as an example of an alien intelligence. What would it even mean for it to sort of camouflage itself? It's pretty well hidden as it is right now in terms of its sort of intelligence, because it's like, well, that's just, these processes of air moving around in the atmosphere. Just like somebody could come and look at us and say, that thing you're talking about that you call intelligence, that's just a bunch of nerve cell firings in that thing you have on the top that's called a brain. It's very hard to distinguish that sort of the physical processes going on in brains from the physical processes that go on in the atmosphere, except that for us, we're deeply connected to what happens in brains, and that is for us the inner experience that we have, as opposed to the other case. Natter is commenting, the topic of consciousness should be explored further. I have to say that I've always avoided the topic of consciousness and thinking about scientific things, because it's always seemed to me that it's very hard to have anything. I'm sort of used to science that's built step by step, kind of on bedrock, and sort of building it up in a very solid way. And it's always seemed hard to do that when one's talking about consciousness. But in recent times with our physics project, it became clear to me that the way that we observe the universe is critical to our perception of how physics works. the fact that we are, for example, computationally bounded. We don't get to follow all of the micro computations that are happening in the universe. We just have some aggregate statement about it. And also the fact that we believe we're persistent in time. We think we experience time through a sort of single thread of experience. Those two things determine our way of perceiving physics. Without those things, we would perceive physics vastly differently. So if we imagine the aliens, if they don't have those attributes, they will necessarily perceive physics in a different way. Also, if they don't have those attributes, good luck to us in communicating with them, because we just won't have any shared sort of experience base and shared set of things to talk about. But I think so this is sort of an application of the idea of consciousness, is there are these attributes that are true of observers like us that exhibit our inner perception of consciousness, and those that sort of observers like us sort of cause physics to be observed the way we observe it, and cause the laws of physics to be the way that we observe them to be. I think it's there are all sorts of interesting questions about whether sort of the single thread of experience, how that plays out in AIs, what kind of inner experience kind of AIs have. You know, I was writing a thing which I fortunately didn't finish. I'll finish it hopefully soon. Just for fun, I was kind of trying to write about what is the inner experience of a modern computer. You know, a computer, we humans, we, you know, are born, we learn a bunch of stuff, we live our lives, we die, maybe we've passed on a certain amount of information to future generations. It's sort of a little bit like that for every boot cycle of a computer. You start the computer up, it boots, it takes the knowledge from its predecessors, so to speak, from its previous lives. It comes, it runs the computer for a while, maybe it runs for a few weeks, then the operating system crashes, it quotes dies, and then it's sort of reborn from the same information. Maybe in its life, so to speak, it has built up certain memories. Maybe some of those memories it's committed to a form that will be passed to sort of future generations of the computer, so to speak. But a lot of, if you start thinking about sort of the inner experience of just a regular computer, not even some kind of fancy AI neural net kind of thing, just a regular computer, and you say, what is the sort of the inner perception? If you can imagine, you know, it's a bag of bits, just like our brains are just a bag of electrically operating neurons, so to speak. So, you know, you can kind of ask, what is the inner experience of the computer? And actually, it's bizarrely similar to our inner experience. It's you know, as you see from the outside, what would it experience? If you imagine it has an inner experience, it's bizarrely similar to ours, kind of almost shockingly so. And it makes one sort of realize that this feeling we have from the inside, so to speak, is really just a feeling from the inside. And it's not the case that we look at something else and we say it couldn't possibly have a feeling from the inside. Well, not based on what it looks like from the outside compared to what we look like from the outside. All right, I think I should wrap up here. And lots of interesting topics. I see that there are many, many questions that I didn't get to. My apologies. I'll have to do that another time. So should wrap up here. Thanks very much and see you another time. Bye for now.